Our presenter this evening is Dr. Lisa Ann Gershwin, a biologist based in Launceston, Tasmania, who has described over 200 species of jellyfish and written and co-authored several non-fiction books about Cnidaria. I hope I didn't massacre that too badly.
It's okay.
Jellyfish and their allies, including Stung in 2013 and Jellyfish, A Natural History in 2016. And I realize I can actually share a screen so everyone else online can see these wonderful books. There we go. No, that is the wrong screen. There we go. Do all the prep, don't we? There we go. There they are. So, yes, as we said,
I'm very proud of
Stung
those books.
and Jellyfish, A Natural History. She provides
And
independent...
shapeshifters.
Oh, and a new one, Shapeshifters. Even better. Lisa provides independent advice related to jellyfish worldwide to the media, online, and via the Jellyfish app. She was awarded a Fulbright scholarship to Australia and awarded a PhD from James Cook University in 2005, and is currently pursuing another PhD at the University of Tasmania. And as I've discovered through our discussions this evening, is now offering glow tours in Tasmania as well. I'm sure we'll hear some more about that very soon. Our interviewer this evening is Alexandra de Blas. Alexandra is an award-winning science journalist, broadcaster, filmmaker, and communications professional. Her boutique consultancy, de Blas Communications, has a particular focus on the environment, climate change, and agriculture. During the 8 years she ran Earthbeat, ABC Radio National's weekly environment show, she received multiple awards, including the Third World Water Forum Journalist Prize and the United Nations Association of Australia World Environment Day Award. She has a Bachelor of Science degree and first-class honours in environmental studies. The SBS Dateline piece on the controversy surrounding her thesis on the Mount Lyell copper mine received a Walkley Award and the Peter Hunt Eureka Award for environmental journalism. We're certainly in fantastic hands for this evening, and without further ado, Lisa, Alex, over to you.
Thank you very much, John. Lisa, the title of today's webinar is Do Jellyfish Taste Like Chocolate? We know that people eat jellyfish in Southeast Asia, but do they ever taste like chocolate?
Well, I was having a little bit of fun with that. Jellyfish actually take on the taste of whatever sauce they're in. So I think if you drizzle them with enough chocolate, yes, absolutely, they taste like chocolate. But the truth is, even though they're a delicacy in many cuisines, I personally find the mouthfeel a bit off-putting. They sort of have a funny crunch, chewy thing to them, where it's like a cross between cucumbers and rubber bands, and it just kind of doesn't work for my mouth. So even though I like chocolate, and if I drizzle them with enough chocolate, they taste like chocolate, for me, it's a no. But look, go for it. If you want to eat them, you can eat them.
Well, since we have got primarily a Queensland audience with us this evening, I thought we'd start off by talking about the most poisonous jellyfish in the world, and they're both based in Queensland, the box jelly and the Irukandji. Tell me about those two jellyfish and your role in discovering them and educating the public about them.
Yeah,
This is the box jelly, yeah.
Yeah, so this is Chironex fleckeri, the so-called the box jellyfish. And this is actually the world's most venomous animal. I mean, this is incredible. And this animal is well deserving of that title. So full grown, these guys get to the box, the body part is about the size of a man's head, and they get up to 15 tentacles on each corner, and each tentacle might be 2 to 3 meters long. And so 15 tentacles in each corner, they end up with about 120 to 180 meters of tentacle, and as little as 3 to 5 meters can kill a healthy adult in as little as 2 minutes. It's really quite incredible. So These really are kind of the Formula One of killing machines. And, they're quite at home in Queensland. It's where they were first discovered. It's where they're most abundant. And yeah, so they're kind of the really bad boy of the bunch. But a lot of people have kind of forgotten about the boxy because up in North Queensland and Central Queensland, where these guys are most abundant, there's stinger nets or stinger-resistant swimming enclosures that keep them away from people's legs and arms and bodies. So there's places that you can actually swim quite safely, even though these might be swimming around the outside of the net. You can swim quite safely inside the net, and you're safe from these guys. Not the case with Irukandji, but yeah, but at least from these guys, we've been able to control them quite well and, with a high degree of safety. The Irukandjis are kind of the one that's on everybody's lips, really. Like I said, people have kind of forgotten about the boxy because we're managing them so well. But the Irukandjis are kind of another ball of wax. So this is an Irukandji. This is the first named Irukandji. Carukia barnesii is its scientific name. And it's actually quite tiny. So the bell that you see there, the body or the umbrella, is about a centimeter high and a centimeter wide. So this was taken under a dissecting microscope. And those tentacles are just fantastic. So, so the animal itself, the body is a centimeter by a centimeter, and they have 4 tentacles that get to be a meter long, 100 times the length of the body. It's quite incredible, but they're as fine as cobwebs. And so they go really, really far when they relax them out. You can get zapped by one of these and not even know it's there. Then, of course, they're so tiny and transparent anyway. But a zap from these guys is really quite not much at all. I think the next slide is a woman who's been stung. Is that right? Yes, here we go. So I didn't put a sting photo from the box jellyfish because they're quite gruesome. They look like a cat o' nine tails burns all over the legs, and it's really quite horrible. And I didn't want to kind of, go there. But the Irukandji is a whole different type of sting. So what we're looking at here, this is obviously a female's chest. She's been stung by an Irukandji. Those aren't blisters. Those are actually sweat beads. So the Irukandji makes the skin sweat at the site of the sting. The redness isn't from the sting itself. It's because she was rubbing it, which unfortunately rubbed in the stinging cells and made more of them discharge their venom into her skin. It was a bit itchy, so she was rubbing at it. And so she made a full and complete recovery. Most people stung by Irukandji do, but yeah, it's quite horrible. She had a hard go. The Irukandji sting starts out with a very mild sting, and then it progresses into nausea and vomiting and difficulty breathing. And then it progresses into full body cramps and spasms and a feeling of impending doom. Some species give hypertension or high blood pressure. This is where we start seeing the strokes and the heart attacks and the really life-threatening outcomes. She didn't have any of that. She was stung by this species right here. I don't know if you can see. There's just a tiny, dinky little jellyfish in there. So this is no longer alive. It's preserved in formaldehyde. But it's my pet. Okay, not really my pet.
We've also
Anyway,
got a slide of that.
I think I do. It might be the next slide actually to show how small they are. Um, and yeah, so she made a full and complete recovery like most people do. John, is the next slide the one of me holding the vial of the jellyfish? Yeah, there you go. So this is I promise, the same vial, same jellyfish. Those are my fingers. Um, And so just to show you how small they are, but there's actually 16 known species of Irukandjis, and this is only one of them. This is the one that was described first. They're not all small. If you go to the next slide, John, we'll see one that's quite a bit bigger. So we can't really tell the size of this one in the photo, but the body is around the size of a large takeaway mocha. And if you go to the next slide, we can actually get a feel for the size differences. So what we're looking at here, the very large one with a whole bunch of tentacles that's facing off to the right, that's Chironex, the box jellyfish. And then this much smaller one off to the left with the 4 tentacles, that's a Morbaca. That's the one that gets to the size of a takeaway mocha. That's a young one, but not very young. It's still quite large. But then way off, the tiny little one that's above the Morbaca and behind the Morbaca, that's a Carukia. That's the smaller Irukandji. So these really are quite small in comparison. Actually, if you go to the next slide, please. So this is a swarm of Irukandjis, and herein lies the problem. One Irukandji sting can be life-threatening. When you get a swarm like this, it can be really, really dangerous. And, they do swarm. Yeah, it could be deadly. Yeah. So they do swarm. Carukia does, but Morbaca doesn't. And this is actually a really handy aspect of Irukandjis, that Morbaca doesn't swarm. So Carukia and several other species are pretty much confined to the tropical north. Like, we don't see them coming south. Morbaca is a type of Irukandji. So that's the mocha-sized one. And this is a type of Irukandji, and it reaches its height of distribution. That is, it's most numerous in Moreton Bay. It's been in Moreton Bay and around the Brisbane area since time immemorial. It was pictured on the front page of the Courier Mail in 1954. So, it's been around for a long time. And so I always kind of, I guess I chuckle a little bit, when people say, oh no, Irukandjis are migrating south with climate change. This certainly is a narrative that we hear a lot. But there's actually no evidence that any tropical species of Irukandji has migrated south with climate change or is migrating south with climate change. That's not to say they can't. It's just to say that they haven't and they aren't. The Irukandji stings that we get in the southeast of Queensland, these are species that are already there. So, yeah, I guess it's all in the advertising, right?
So with climate change, could the box jelly move further south? Will we be seeing people sporting stinger suits in Broadbeach?
Yeah, maybe. So, yeah, as a matter of fact, there was a very severe sting at Broadbeach on the Gold Coast, Easter Saturday of, I think it was 2014. I'd have to double check the
And that was a
exact
box
date.
jelly.
That was a box jelly at Broadbeach on the Gold Coast, and resulted in cardiac arrest. The girl had to be resuscitated, and thankfully she was successfully resuscitated. But yeah, so even though we think of Irukandjis and box jellies as something in the north, they can be around, as we've seen.
Now, I'd like to go back to how it all started, Lisa. When did jellyfish first wrap their tentacles around you?
Well, it was it was about shortly before noon on the 21st of December of 1992. You probably
very
weren't asking
precise.
for that specificity. Welcome to my world of neurospicy. Dates stick in my head and they never come out. So yeah, I was at a public aquarium in Los Angeles and I came around this bend and there was this aquarium of these jellyfish and they were magical. They were truly magical. They were hanging in the water, drifting really slowly like clouds in the sky. And they just, yeah, they were like living lava lamps. And to me, they still are. I'm still just as enchanted with them as I was that day.
Well,
I just love them.
you have discovered, named, and classified 200 species. Like, that is incredible.
Yeah, but wait, but
So
also one
how did
dolphin.
you come to find and classify so many?
Wait, and also one dolphin. You got to
Oh,
remember my
and the
dolphin.
dolphin. Yes,
Very
okay, the
proud of my
dolphin.
dolphin. You know,
Yeah,
as
but
a
I want to know
jellyfish.
about the jellyfish first.
All right. But as a jellyfish scientist, you don't expect to discover a dolphin, you know? So look, discovering jellyfish is what a privilege. What a privilege. Some of them I've actually gone out and netted and found, and it's like, whoa, you know, look at it under the microscope and go, okay, look at that. That's interesting. You know, that doesn't link up with anything known. Other ones, people have brought me specimens or photos, and then I go out and find some, whatever, you know, they come to me in different ways. And yes, I'm really, really lucky. And I mean, I'm sure this is kind of an Aspie thing, but I'm really lucky in that I have kind of a card catalog of sorts in my mind. And when I see a jellyfish, a photo or a specimen or, you know, whatever, my mind kind of goes, you know, and I kind of superimpose the critter with what I know of different species. And I'm able to kind of pick out quite quickly, like, wait, what's that character over there? Or wait, why isn't that character there? And so I never tried to do this. It just kind of happened. But I think it gives me kind of an edge to be able to really home in on features of jellyfish that you know are important or not. But well, I mean, what an amazing world of things we have yet to discover. And you know, like one of my new species, actually my very first new species, and I think we have a photo of it. John, if you can pull up the one that's the largest. It's the black and white photo with the guy looking at this jellyfish going, whoa, this one. So this is actually my first new species that I discovered. And this was the largest invertebrate that was discovered in the 20th century. It's the color of Shiraz wine. It's just gorgeous. But the reason I've chosen to go with this black and white photo is because I love the look in this guy's eyes where he's looking at this thing like, whoa. And it gives a
That
real, sorry?
is this venomous? Is this a nettle or?
Yeah, this is a sea nettle, so
Yeah.
named because they sting, obviously. All jellyfish sting. They're all venomous. They all have venom, but some of the venoms aren't very powerful, and most of the venoms aren't dangerous to us past a little bit of an annoying sting. But very few are actually life-threatening or anything like that. When we discovered this one, we suspected it might be life-threatening simply because of its sheer size, and that if you got wrapped up in it, you'd take a really huge venom load from this thing. We now know that that's not the case. It's not as venomous as we thought it might be, but it does sting. I mean, it'll get your attention. But yeah, so this is my baby. So this one's called
So
Chrysiora
show us your
acleos.
smallest one then. That's your
Yeah,
largest.
so John, the next one is so this is my smallest species that I've discovered, and this one is called Syromedusa, named after CSIRO, and it's my very smallest species. The whole diameter of it is about 1 to 2 millimeters. It's the size of the head of a small pin. It's a tiny, tiny little creature. And it's funny, the name that I gave it, I should say, so Chrysiora acleos, I got a little bit, like mystical and magical. So Chrysiora acleos translates in Greek to dark and mysterious god of the sun. So that's the big one. With this one, I just couldn't walk past the perfect name. So that white bit that you see in the middle, we don't have the right angle to see it, but that's actually the reproductive organs that stick up through the head, and they look like icebergs or like skyscrapers in a city like Gotham or something. And so I named this one Medusa Medeopolis, and Medeopolis is Greek for city of gonads, because it looks like Gotham. Like, it's crazy, right? So as the one who names these things, you get to be really creative and get to have some fun. So that's always nice.
I'd like to now look at we're in the Anthropocene, and humans have had an impact on every inch of the earth. And in your book, Stung, you documented the impacts of human exploitation of oceans and waterways, and how they're creating ideal conditions for jellyfish to thrive. And once an ecosystem flips, it sometimes can't flip back again. It goes to a new state of equilibrium. And I'd like to hear a bit about that and the role that jellyfish can play in that. And then perhaps we can talk a bit about Tasmania, because I see a Tasmanian salp in front of us.
Yes, indeed. These Tasmanian salps are fabulous creatures. So jellyfish are incredibly simple creatures. I mean, they have no brain, they have no spine. They have no skin, no bones, no visible means of support. They're just these incredibly simple animals. And but they do something that's unbelievably simple, but unbelievably damaging to the ecosystem. So they can exploit a damaged ecosystem. So in a nice, healthy ecosystem, jellyfish aren't able to, shall we say, overpower the fish, right? Like, the fish have the upper hand in a nice, healthy ecosystem. But as an ecosystem starts to falter and the fish, we get lower numbers of fish, maybe through overfishing, or maybe through pollution, or maybe through lower oxygen, or, whatever. When the fish become in lower numbers, the jellyfish make up that biomass, and the jellyfish population starts taking over, and it becomes kind of a like they're in equilibrium like that, and then as this one goes down, this one comes up, and then it drives it more and more, like you get more of these. So what happens is the jellyfish are both predator and competitor of fish eggs and fish larvae, and also the the plankton that the larvae would eat. So this dual role of predator and competitor can actually cripple an ecosystem. And so what we see is these jellyfish blooms, and it can be a little bit confusing, because jellyfish bloom as a natural part of their life cycle. So we see jellyfish blooms every year, every spring, they just go, and then they go away, just like any flower or any insect that you might see in the garden or anything like that. You see them and then they're gone. But some blooms are so huge that they make us sit up on our chair and go, what? And some blooms persist over a really long time and make us sit up on our chair and go, what? So it just depends what's going on with jellyfish. Now, when I wrote my book Stung, there had been many, many hundreds of jellyfish blooms that had been documented around the world. And I had no shortage of material to draw from to write about these jellyfish blooms and the causes and the effects and the mechanisms and all of that. So I was really lucky there. But the worst jellyfish blooms that I knew of or anybody knew of had two types of jellyfish back to back blooming. And so what happens is when jellyfish bloom, because they eat the eggs and larvae of fish and other species and the plankton that those larvae would eat, they cripple an ecosystem, but it's usually quite brief. When the jellyfish die off, everything goes back to normal, right? But in a damaged ecosystem where you get more jellyfish and they exert more pressure, and then there's more jellyfish that eat more eggs and larvae. So what happens is the fish and the other species can't come back because every time they have eggs or larvae, they get eaten right away. So we see these weird effects happening in the ecosystem. Now, going back to this thing where I said, when I wrote Stung, we had two back-to-back blooms was the worst that we could imagine and actually documented. And these are tremendously devastating to local fish populations, but the whole ecosystem, not just fish. I mean, everything that eats fish. So, dolphins and seals and seabirds and people and just everything. This year, I guess you could say, broke through a new boundary that we kind of never really should have broken through this boundary. In Tasmania, we had 3 back-to-back blooms, and it's been really devastating. So in November of 2024, we had these salps. So on the screen in front of you, these are salps. They're these weird jellyfish-like organisms that they look like jellyfish, but they don't sting. They're actually in our phylum. So they're more closely related to us humans than they are to jellyfish, but they look very jellyfishy. They don't sting, but they do lead to deaths of fish. And so these salps absolutely devastated lots of fish. Well, by devastated, okay, let me just call it what it is. They killed a lot of fish, okay?
And do you know what triggered the salps in the first place? Was it high levels of nutrient or what was going on?
Yeah, that's exactly. So it's high levels of nutrients. In this particular case, we had a very strange thing happen in November. It was kind of a quadruple whammy where we had the normal human sewage that's treated and it goes into the water. But we always have that. And so that, raises the nutrient level a certain amount. And then we had the fish farm sewage that goes into the water. So this is farm salmon that release a huge amount of nutrients into the water. Nutrients sounds good, like, ooh, nutrients, that's nutritious. But in this particular case, nutrients means sewage. And too much is not a good thing. And so that raises the nutrient load even higher. So you've got the human nutrient load to here, you've got the salmon load up to here, like exponentially higher. And then we also had a normal seasonal upwelling, which is just a natural normal phenomenon that brings nutrients from the deep water up into the shallow water. And we had a big rainstorm, which brings nutrients off the land, and we're talking agricultural, fertilizers and cow stuff and rotting trees and possums doing their thing by the river and miracle grow in grandma's garden and dog poo on the sidewalks and whatever, all this washes down into the water. So we had these 4 things all happen at the same time. And because the nutrient load was already quite high because of the human, the little bit of human input and the giant amount of aquaculture input, it was just too much. And so these salps responded by blooming into this unbelievable superabundance. I mean, it was just gobsmacking. So Storm Bay, which is this big giant bay south of Hobart, it's like this whole giant water thing, giant bay that opens up to the Southern Ocean. So Storm Bay, north, south, east, and west, was full of salps. And about halfway up the Tasmanian coastline, up to Coles Bay, was just socked in with salps the whole way. It was just unbelievable. And
Have you
then
ever seen anything to that
no,
extent before in terms of
nothing on
salmon?
a scale like this. Nothing on a scale. It was off the scale. It really was. And I mean, photos that were coming to me and reports, and it was just off the scale. So when the salp started dying off, this created a pulse of nutrients again, because, all those salp bodies decaying away, all that nutrient becomes released into the water again. So this led to another phytoplankton bloom. Excuse me. And then something else took its place. Now, when the salps bloomed, I knew we were going to get jellyfish after that. And I was saying, oh, this is going to go badly. This is going to be another one of these, double whammies of these two blooms back to back. But that's not what happened. The Noctiluca scintillans, which is the bioluminescent algae that, we get in huge numbers down here sometimes. I love this
Also
photo.
known as a red tide during the day.
Yeah, that's right. Yeah. And so the Noctiluca, or the bioluminescent algae, bloomed into these ridiculous superabundances. Again, we had never seen anything on this scale. And it was the same footprint as the salps. So it was all through Storm Bay, north, south, east, and west, and halfway up the east coast. Same footprint as the salps. Ridiculous numbers of these algae. And then when the algae started dying off, we got this pulse of nutrients coming back again. Oh yeah, here's Noctiluca, just having a little bit of fun playing with it. But as the Noctiluca started dying off, again, we got another pulse of nutrients, and this led to another one of these visible indicators. This is where we got the jellyfish, the moon jellyfish. And so I think we've got a couple of photos of the moonies here. Oh yes, I'm very fond of these guys. So these jellyfish, when they get into superabundances, they sting, but they also release a lot of slime into the water. And this slime is particularly dangerous for fish gills because it clogs up the surface of the gills, and they can't get oxygen across the surface of the gills, and they simply die. And it's not uncommon to lose millions of fish in 30 minutes. Like, it's crazy. So this is what we saw. Oh yeah, here's an example of a few moon jellies, right? But this was in the same footprint, again, all through Storm Bay, north, south, east, and west, and halfway up the east coast of Tasmania. So we saw these
But
three.
this is at the wharf, but
Yes, but it was these same
in
numbers all the way.
Hobart, yeah.
Yeah, but it was everywhere. It was
Yeah,
absolutely everywhere. So these are all three each visible indicators that something is out of balance in the ocean. And they're not only visible indicators of imbalance, they're drivers of even more imbalance. And so what happens when all of these things are killing fish and then changing the ecosystem? Well, you end up with a lot of dead fish. And that's exactly what we saw. John, if we can get the next slide.
But I think
So,
we should be clear that a lot of the fish that died were from a bacterium, which is separate to the jellyfish. So can you be clear
yeah,
about that relationship?
absolutely. Yeah, absolutely. So salps, just going back to this whole weird triple whammy that we saw, salps kill the fish by The fish eat them because they're about the size and shape of popcorn. And who doesn't love to eat popcorn, right? So the fish eat the salps and they get a toxic bullet. And it fills up the gut with these toxic algae that the salps have been eating, and they kill the salmon. And the Noctiluca scintillans kill the salmon by suffocating them and also a bit of toxicity. And the jellyfish kill the salmon by clogging up the gas exchange surface on the gills. But all three of these things also injure the gills, injure the salmon, weaken the salmon, reduce their their ability to fight off infections, and they leave the salmon in a more vulnerable state. Now, they probably do this with all fish, but unfortunately, nobody's studying the other fish. We don't know. The studies are only on the farm salmon. But all three of these leave the salmon in a more vulnerable state. And then they're more vulnerable to a bacterial infection. And that set in after the whole jellyfish and everybody else before them thing. And it has been simply unbelievable down here this year in terms of the gobsmacking numbers of fish that have been lost to these blooms and the bacterial infection that followed. So, here's an example of what happens when jellyfish exploit an out of balance ecosystem. And unfortunately, this is probably what the future looks like, not only in Tasmania, but anywhere where we are damaging ecosystems enough that the jellyfish are finding a foothold, or I guess you could say a tentacle hold. It's really quite scary what jellyfish can do to an ecosystem because they're so simple, you just wouldn't expect it.
Well,
That's how they
something
do it.
that we wouldn't expect is what happened in Brisbane with the SS Ronald Reagan. What happened there?
Yeah, so this is amazing. So this was in 2006, March of 2006. And actually, John, can we go to the first blubber photo, please? The white one with the blue rim. Yeah,
What a
here you go.
beautiful creature.
They are beautiful. So this is the blubber, Catastylus mosaicus. They come in a variety of different colors. This is the one I love the most. I just think it's so beautiful with that ghostly white with the blue rim. But most Southeast Queenslanders see them more as solid blue. John, if we could get the next photo, please. So this one's a little bit high and dry. Sorry about that, but it is what they look like. So this is actually the one that I'm going to talk about with what happened in March of 2006. But I just want to go to the next slide because they do come in another color morph. So they come in this brown color morph as well. The brown ones tend to be farther south, more in New South Wales. And then actually, John, if you go to the next slide with the bloom of the red ones. So this bloom of the red ones, this is actually a different species, but I wanted this photo because it shows when they're in these bloom conditions, these things are just absolutely numerous. So in March of 2006, okay, I'm going to try not to describe it as hilarious, but I'm sorry. As an American Australian, I actually find it a little bit hilarious. So America's biggest, most expensive, brand new nuclear supercarrier, the USS Ronald Reagan, pulled into the port of Brisbane. It was on its maiden voyage and it was its first port of call. So this was a newly minted, brand new, brand spanking new nuclear supercarrier. It was built to withstand anything that any nation's military or nature itself could hurl at it. This ship was built to stay at sea without refueling for 20 years. This was an insanely tough ship, right? But they didn't call me and say, hey, is there any problem we should be thinking about? Because when they pulled into the port of Brisbane, they sucked thousands of blubbers into the intake for the cooling system. So the cooling system works like this. You've got these engines, they run really hot. They need cooling water to cool off the system. Easy. Okay, not so easy when you have these screens that they keep stuff out, right? Because jellyfish are just these passive drifters. And when there's something pulling water in, they just go right against it. They act like plastic. And that's what happened. Thousands of these blubbers got sucked into the cooling intake and shut this sucker down. Now, it's kind of hilarious in most cases. It's like, oh, well, you know, big American ship gets shut down. No, man, this was a nuclear ship. You don't want your nukes getting shut down, right? So this could have gone really badly. Now, it didn't go badly. Everything was fine. They had to emergency evacuate 6,000 people from this ship. Not an exaggeration. But everything was fine. They shut everything down and they got the jellyfish out and they restarted it. And I think it's safe to say they got the heck out of town. So it was actually more than a decade before the USS Ronald Reagan came back to Brisbane. I think it was kind of, you know, the admirals would have said, oh, no, no, not there.
No, not
So,
there.
I mean, so it's a little bit funny, but it's also a little bit eye-opening.
Terrifying. Yeah. So we very soon will come up. I'd like to throw open the floor to our audience. And so the way that will work is that you type your questions into the chat and then I'll read them to Lisa and we'll work it like that. There is one question. Is there such a thing as a pest species of jellyfish or places where they damage the environment? Well, I think you've answered that question quite brilliantly.
So I'm just going to add to that. Yes, there is a place where that happens. It's called planet Earth.
Yeah.
So pretty much every marine and some freshwater areas have jellyfish problems.
So while people are wanting to type in their questions, I'd like to talk about sex. And jellyfish have two ways of doing it. There's asexual reproduction with a polyp or hydroid stage, and there's also sexual reproduction, and that's when the medusa creates the male and female gametes and then they sexually fertilize. But so can you tell me in a bit more depth about jellyfish sex?
Oh yeah, look, jellyfish sex is amazing. So, wow, yeah. So many jellyfish are hermaphrodites. So you get a single individual that's both male and female. They're not usually male and female at the same time, or there are a few of those, but they're usually more sequential. So they start out as male, then become female, or start out as male and become female, or whatever. But they're just crazy weird, right? But the asexual is actually the part that I'm the most intrigued by. Jellyfish are able to clone in 13 different ways. So you think about this, like cloning itself is amazing, right? But they can clone in 13 different ways. So they've been around for 1 billion years. 1 billion, not an exaggeration, 1 billion years. And in that time, they've figured out how to survive. And they are unbelievably good at surviving. And I think the take home message to their ability to clone in so many different ways is that they will find a way to survive, whatever it is. One of my favorites, actually, just to show you how tenacious these things are. So when you've got the hydroids, these little like hydra things, they're like these little plants, you know, they wind around things. So you get a rope, for example, on maybe an aquaculture facility or a marina or something. You get a rope and the tendrils wind around in between the fibers of the rope. And so you see this bushy thing hanging off of it, and you go, oh, let's just get rid of that, and you wipe it off. No, man, they like that. So the action of wiping them and tearing them off stimulates them to grow even faster, to regrow even better. And the parts that you wipe off, those become little fragmented bits that act as seeds to create more hydroid colonies everywhere, like down flowing, downstream that these go. And so the act of trying to get rid of them, it's uh, like in Fantasia, there was the broom sequence. Remember
Yeah.
that? Where like they try to kill the brooms and the brooms are multiplying and there's more brooms and more brooms. This is jellyfish. This is what they do. And they do it mostly through their cloning. But their sexual reproduction is pretty crazy too. So when yeah. So, well, okay. The thing that got me my Fulbright actually, and I'm still quite fond of this research, but I never figured it out. Oh, Praj, I know. Where are you going? Hi, Praj, if you're my Praj. Sorry, I just had to. I'm very fond of it is. Hi. Very fond of that man. Um, so sorry, I forgot what I was going to say. So jellyfish, when they have their sexual reproduction, well, actually, let me go back. So cloning is where we think of things being exactly the same, identical, right? Whereas sexual reproduction is where we get the change. So children might look a bit like their mom and their dad, but they're not identical to their mom or their dad. They're a blend of their mom and their dad, right? With jellyfish, it's different. So the clonal stage is where they become more variable, and the sexual stage is where they reset to being the same. It's crazy. It makes no sense. But this is jellyfish. So many things they do make no sense, which
Well,
is
now
why I love them.
I'd like to go to the first question. How
Yeah.
much do jellyfish vary around the world? And are there any biogeographical patterns that you particularly find interesting? And do they fulfill mostly similar or very different ecological niches? Good question.
Oh, holy cow. Okay, there's at least 3 questions in
Yeah.
there, maybe 6.
So how much do jellyfish vary around the world?
Um, Well, it's interesting because there's actually numerous groups that we call jellyfish, and each of these occurs all over the place. So we have proper jellyfish, which are the, the part up here with the hanging down bits, right? So proper jellyfish that sting. And those are all over the world. Every marine habitat from the deepest part of the Marianas Trench to the surface and tropical to polar, pole to pole, and in between. And so those are everywhere. And then we have what we call comb jellies, like comb your hair. They don't sting, but gosh, are they cool. They are seriously the coolest things in the world. I secretly think they're from outer space. Oh, sorry, I'm not allowed to say that. Sorry, I don't really think they're from outer space. Maybe they are. Anyway, they're very cool. And so they also occur all over the world. And then we have these other jellyfishy things, the salps that I showed earlier, that are in our phylum. They don't sting. They're not proper jellyfish, but they look very jellyfishy. And those are also all over the world. So the variation isn't around the world as much as it's in the different groups of jellyfish. With that said, I mean, there are species that are found in different places. Like, yeah, look, Irukandjis are pretty much from 40 degrees north to 40 degrees south. Boxies are pretty much from 30 degrees north to 30 degrees south. Lion's manes and sea nettles are pretty much temperate to temperate, except for the biggest jellyfish in the whole world, Cyanea arctica, which only occurs in the Arctic, and it's 3 meters across the body, and the tentacles get to oh gosh, what is it, about 50 or 60 meters long or some insane thing like that. I mean, there's just this giant animal. But there's other lion's manes that occur around the world. Like, we've got 3 lion's manes that are new to science here in Tasmania alone. And some years ago, I discovered a new species of lion's mane in southeast Queensland. And my favorite lion's mane is in the Irish Sea. It's my favorite because it causes Irukandjis syndrome. And it was the subject, well, it was actually the murder weapon in a Sherlock Holmes story. I mean, you gotta love that. Come on, right? So it's, yeah, I mean, there are different species found in different places, but we have that with everything. You think about birds, you get some birds that are only found in Australia and some birds that are only found in, I don't know, pick a place, right? Kiwis are native to New Zealand, et cetera, et cetera. Yeah, anyway, sorry. I hope that answered the
your
question.
friend Praj, he has made a
He
comment.
has a chicken on his shoulder.
He's made a comment about the immortal species, the Teratopsis.
Teratopsis, yes.
Teratopsis. He couldn't remember its name, but it's a Mediterranean species. Now,
Yes.
tell me about how it is immortal and how does that work?
Oh, it's amazing. So you think about, through all of human history, several things, several questions and things that humans have wondered unite us all, no matter what language we speak, no matter what eon we come from, no matter which part of the sky we're looking at. I think we've all looked at the sky and wondered what it would be like to go to the moon. And we've all looked at loved ones and who are dying or deceased and wondered what it would be like to live forever. And so here's the thing. Teratopsis, we see on the screen now, does not go to space, as far as I know, although there has been jellyfish in space. It's a whole nother story. But
Yeah.
Teratopsis is the first truly biologically immortal organism known. And Teratopsis is absolutely remarkable. And I don't think in all the thousands and thousands of years that humans have been wondering about immortality, I don't think anybody ever thought it would happen in a jellyfish first. But there you go. There's
So
jellyfish.
tell us how it works, because we haven't got long.
Okay, I'll make it quick. So the jellyfish itself dies, and I mean, it usually happens in a laboratory with them squishing it, right? And sinks to the bottom, and the cells disaggregate. It starts, falling apart, right? And it turns to mush. Then something amazing happens. Instead of it continuing to turn to mush and everything just, disintegrating, the cells reaggregate. But instead of turning into another medusa or the jellyfish stage, they reaggregate into the polyp stage, which is the other part of the life cycle that then buds off baby jellyfish. And so what happens is it never dies. The jellyfish simply reaggregates into polyps, buds off more jellyfish, which then reaggregate into more polyps, et cetera. They've taken it in the laboratory through something like 20 generations of this. I mean, it's mind-blowing. It's so cool. That's jellyfish.
It's so like out of space, really, isn't it?
It is. It
And
really,
I think that when I saw your book, Shapeshifters, I thought really jellyfish are so amazing. like the bar scene in Star Wars is just nothing compared to jellyfish. They're just wonderful. And on that note, Lisa, I would like to thank you so much for your enthusiasm, your curiosity and wonder, and your imagination, and the fact that, well, you can see why you're one of Robin Williams' science show top 100 science communicators in Australia. Everyone can see that here
Thank
tonight.
you.
So thank you very much.
My
Over to
pleasure.
you,
Thank
John.
you.
No, I'd just like to reiterate that. Lisa, Alex, thanks so much for your time this evening. Absolutely fascinating. So many more questions, but we're out of time. Thank you again. We will be putting the recording up online fairly soon, and do look out for upcoming events as we've got more on in the RGSQ program. With that, everyone, have a safe night, and we'll see you at another event very soon.
Thank you.
Thank you. Bye-bye.